Howdy everyone. So for this video we are going to be doing a concept of relating delta E, which is the change in internal energy, to heat and work. This is a concept in chapter 5 for Chem 204 or Gen Chem 1 students, and this is basically the equation that you're going to be using. So delta E is the change in internal energy. Now this can be in either units of joules or kilojoules. It does depend, right? Q is actually a unit for heat. This can be in either joules or kilojoules, right? And W is work. This one's a little harder for us to understand, and I really highly recommend you reading the book, but we're just going to be doing some really simple problems here. But work is where you actually travel over a distance, right? It's actually a pushing kind of situation. So this is going to also be in either units of joules or kilojoules. Now, why do I keep saying that? If you're to add these two together, you want to make sure that they're both in either joules or kilojoules. You want to make sure that they agree, right? So let's just go ahead and do a couple problems. I'm going to explain what the terminology means in these problems. There are 3 that I have prepared. So the first one says, why don't you calculate delta E for a system that releases 18.2 joules of heat and does 12.9 joules of work to the surroundings. So if you have a system and you have the surroundings, right? If you are releasing heat, does that mean that you're gaining heat or you're losing heat? So the heat, it's losing the heat, right? As far as my system is concerned. As far as my system is concerned, we're losing heat. Now, if my system does work on the surroundings, which an example would be an expansion of a balloon, right? If you were to do a work on surroundings, then you would be losing heat. So the 2 things that tell me, if you release heat, the Q is going to be negative. What would be the opposite of that? Gaining heat, receiving heat, absorbing heat, right? So other ways that we could say release heat, you could say loses a certain amount of heat, releases a certain amount of heat. So that tells me that my Q is negative. How about for my W? It says it's doing work to the surroundings. So it's doing work to the surroundings. So there are a couple ways to think about this, but if you're doing work to the surroundings, does that mean that you're receiving the energy or you're having to do the energy? The system's having to do the work to the surroundings. So the W in this case is also going to be negative. We're going to go over a couple more examples, so don't worry if you don't catch this just yet. So the first thing that you have to do is you have to define if your Q is negative or positive and your W is negative or positive, and then we plug them in. So delta E is going to equal, and since we determined that my heat is negative, it's going to be negative 18.2 joules, right? Minus my 12.9 joules. I know I kind of cramped that in there, didn't I? But they're both negative. So you can calculate that out. Negative 18.2 minus 12.9. So overall, my system, the change in my internal energy, loses 31.1 joules. Having a little hard time today. All right, here we go. So let's look at some other wording, some other verbiage, because I have 2 other examples. So how about we calculate the delta E for a system that absorbs this much energy while the surroundings do that much work on the system. So let's analyze this information. So my Q is clearly the heat, right? Now if it's absorbing the heat, is it gaining the heat? Is it a net positive? Or is it losing the heat? It's a net negative. it's gaining the heat. It's absorbing the heat. So my Q is going to be positive for this situation, right? How about my W? Is my system having to do work on the surroundings, or is the surroundings doing work to my system? The surroundings are doing work to my system. So the work is also going to have a positive sign. It's receiving the work. You could think of it that way too, like maybe an exchange, right? The system itself is receiving the work. The work is going to my system. So, highly recommend reading the book. It's actually quite helpful on explaining these kinds of topics, but I'm just doing some kind of really scant explanation. So my delta E is going to be my Q plus my W, my Q term and my W term, and we just determined their signs, right? So it's going to be 66.1 kilojoule plus, and this is going to be positive as well, 44.0 kilojoule. So then you just have to combine those two. They're both kilojoule, right? So we can add them together. What if one was joule and the other is kilojoule? You just have to convert so that they agree, and then you can add them together, right? 66.1 plus 44, we have 110.1. And it's positive, right? Positive 110.1 kilojoule. So I just threw that positive right there to really emphasize that it's gaining this much energy. Now let's look at the next one, because it gets a little, I think I have a positive and a negative in this one, because they're not always going to agree. So what's the delta E for a system that absorbs 87 joules of heat, and it does 22.9 joules of heat to the surroundings? So my Q in this case, is it going to be positive or negative? Is my system basically receiving this heat, or is it getting rid of it? It's receiving the heat, so it's positive, right? It's going to gain this heat. How about my W? Is my system having to do work on the surroundings and lose that energy? Or are the surroundings kind of giving it energy? It's doing the heat to the surroundings, right? It's pushing, basically this would be an example of a balloon expanding. My system's the balloon, it's having to push air out of the way so it can expand, right? So this would be an example of a negative, because it's doing work to the surroundings. So it's going to have to lose that energy. If your balloon's expanding, it's having to lose energy, however much energy it takes to push out the air, the surroundings, right? So my delta E for this case is going to be whatever my Q is, and that's going to be positive, so 87.0 joules. And this is going to be negative, so it's going to be 87.0 joules minus 22.9 joules. So let's go ahead and do that. We get a net positive 64.1 joules. So that's a very scant and pretty brief explanation on how to relate heat and work to delta E, but I do hope this helps.